a good scientist tries to check their own biases, but understands that the more they want something to be true, the more careful they need to be.
Science does not need to be boring. The mainstream of astronomy is trying to be as boring as possible by not seeking the evidence that we can retrieve if we were to allocate the billions of dollars that are put into looking for microbes.
So it was the French astronomer Urbain Le Verrier who discovered Neptune, by the way, by seeing a tiny glitch in the orbit of Uranus, and Newton's laws told him that there had to be another planet out there, and he looked and there it was. And this was an incredible success. He became very famous and spent the rest of his life looking for Vulcan, and he found it twice. 2 times he found a speck, and he claimed that Vulcan had been discovered. And so here we have this interesting case where someone wanted something to be there so much that he found it, and we see what we expect to find.
Is there positive reason to think that extraterrestrial life exists? And is this really at the core of space exploration?
There is no current evidence that is broadly accepted, let's say. There are tiny traces of things that seem to have extremely reasonable naturalistic interpretations as well. So there have been a few things like, you know, the wow signal, this weird little radio bleep that was detected a few decades ago that couldn't be explained at the time, but now has a naturalistic explanation. There are things like the Oumuamua object, which fell into our solar system. Again, there are reasonable naturalistic explanations, and my philosophy is that because I want it to be alien so much, I should be very wary of assigning that cause to anything I see until everything else has been so thoroughly ruled out, or something is absolutely clear. So because there's no evidence right now, I think that alien life is probably very rare. I don't think it doesn't exist. I think, as Carol mentioned, that simple life is probably relatively abundant, but technological life, so many of you are familiar with the idea of the Fermi Paradox. Enrico Fermi, during part of the Manhattan Project phase, I think, was sitting at lunch with some other physicists, and the conversation was about aliens, and he asked the question, where is everybody? Referring to the fact that the night sky that we survey, even back then in the 40s, seems very natural. It seems absent any strong signs of intelligent manipulation, let's say, and certainly no clear signs of them on Earth. But for a galaxy so vast as our own, with a couple of 100 billion stars, which we now know almost all have planets, and there are 10 billion Earth-like planets around Sun-like stars. So if life is common, even if it only forms on Earth-like planets, then it seems to very rarely become technological. Otherwise, given the time scale of our galaxy, at least one of them should have made their way to being visible to us. And I also think that I could talk more later, I've talked for a while, I think us being one of the few makes perfect statistical sense. And I'm happy to elaborate on that, but I've spoken for a minute.
Sure. Avi, how would you respond to that? Is there positive reason to think that extraterrestrial life exists?
Well, I think it's arrogant and presumptuous to think of intelligence as our own, as if we are the pinnacle of creation, and as if someone else existing out there would be an extraordinary claim. I think it's a very ordinary claim. We are not that impressive. And science does not need to be boring, which is to say, we are unique, There is no clear evidence for someone else out there, and therefore we should not seek the evidence. Science is all about seeking the evidence, and it could be exciting because this is an important question that society is interested in. That taxpayers are paying money to fund science, and they care about this question. So how come colleagues from the scientific community resist the possibility that some unusual phenomena that we are observing could be associated with extraterrestrial intelligence, and that we should seek evidence to figure it out? What you hear from the mainstream of astronomy is, no, we don't have evidence, this would be an extraordinary claim, and therefore let's put it to the periphery of science and just look for microbes. Of course, finding microbes would still maintain our sense of superiority, because we eat animals that have lower intelligence than we have, and we might obviously maintain our dignity as the most intelligent species if we find microbes. And indeed, microbes might be much more abundant because they are easy to produce. They are not very complex as intelligent as human brains. But the thing to remember is, it's not about how abundant different forms of life are. You can have microbes everywhere. The signatures of microbes are subtle. They change the composition of the atmosphere. But even if you find oxygen, methane, carbon dioxide, water in the atmospheres of planets, it will not demonstrate beyond a reasonable doubt that the life exists out there. However, if you find a gadget at the bottom of the Pacific Ocean that came from another star and it was not produced by humans, or if you detect some other technological signature from a distance, it would mean not only that life exists beyond any reasonable doubt elsewhere, but that is also an intelligent form of life that we can get inspiration from. And so my argument against what you hear from Matt, for example, is that the mainstream of astronomy is trying to be as boring as possible by not seeking the evidence that we can retrieve if we were to allocate the billions of dollars that are put into looking for microbes. And why do I say billions? Because, we went to Mars, and even NASA is very hesitant from repeating the Viking experiment, putting a drop of water on the surface of Mars and seeing what comes out of the soil. There is this conservatism of, no, we haven't seen anything unusual yet, and let's not try to do that, because that will be extremely controversial, and we should not talk about it. And in my mind, that suppresses the childhood curiosity which is supposed to power science. We should all wonder about the big questions and use the resources we have to follow those questions, rather than trying to figure out what the dark matter is. Billions of dollars, we haven't found it for 50 years. Matt is not mentioning the fact that, a lot of people speculated on dark matter. We spent billions of dollars, including in the Large Hadron Collider, haven't found the dark matter, but that was not outside the mainstream. That is not a waste of money. That is not an extraordinary claim that the dark matter is made of WIMPs. For 50 years, we didn't find WIMPs, weakly interacting massive particles. That's not an embarrassment for the mainstream. However, let's not put even 1% of the $1 billion into searching interstellar objects that could be of technological origin, because psychologically, no, we are the smartest in the universe.
Are you speaking there about Oumuamua? Can you tell us a bit about that and your thoughts on that?
Yeah, so the thing is that only over the past decade, astronomers discovered the first objects from outside the solar system. The first reported one was Oumuamua with a telescope in Hawaii, and it was the size of a football field, quite big. And the amazing thing is that as it was rotating, actually tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. That's a lot. Usually, most of the rocks that we see in the solar system, as they tumble, the amount of sunlight reflected changes by up to a factor of 3. This one was a factor of 10, and actually the best fit to the variation of light was that of a flat object. There is a scientific paper published in monthly notices of the Royal Astronomical Society saying at the 92% confidence level, this object was flat, pancake-shaped. Okay, so here you have it, an extreme geometry pancake, flat object. Then it showed push away from the sun without any cometary evaporation. There was no evidence for dust or gas around it. So what was pushing it if it's not the rocket effect? And I suggested it's just sunlight. Now, a few years later, another object discovered, pushed by sunlight. That ended up being a rocket booster that was launched in 1966 by NASA. So why would we not consider on the table the possibility that Oumuamua could have been manufactured technologically? Why? Because the public pays attention to that. My paper on this subject was accepted for publication in the Astrophysical Journal Letters within 3 days. And the referee said, this paper makes a lot of sense because the object is extremely weird. When did I start getting pushback from people like Matt? When was it? When the public started getting interested, when the media paid attention. Because the strongest force in academia is not electromagnetism, it's not gravity, it's jealousy.
Well, Matt, I will let you come back on that in a second, but Carol, I'd love to hear what you have to say on this topic.
So I think that was a bit harsh, Avi. I really do. So let me say a couple of things here. One is, Matt is right that there is reason to believe that technological civilizations are rare. Look at how long it took. We have first evidence of the origin of life 4.1 billion years ago. And we don't have any sign of true multicellular organisms, plants and animals, until less than 1 billion years ago. So there are reasons to think technological intelligence is rare. However, and now I'm going to side with Avi, I think, yes, I'm a philosopher, so I get to do this. I study the role of anomalies in scientific discovery. And one of the things that you see, and I'm going to give you some examples, is that the scientific community tends to be really resistant to exploring something that is viewed as an anomaly, as challenging our current scientific beliefs, which may include scientific theories that are well established or just scientific dogmas. And let me give you an example, a very famous one, the precession of the perihelion of Mercury. So it violated Newton's theory, and this was known for hundreds of years. When they first observed it, the view was, oh, our instruments are inferior, it's just a matter of experimental error, we just can't, our instruments aren't accurate enough to get the orbit right. As the telescopes got better and it became clearer and clearer that the orbit was really strange, it's an elliptical order that actually precesses. People then began to say, well, astronomers, maybe there's a planet. They even gave it a name, Vulcan. They were so sure it existed between Mercury and the Sun. And it's gravitationally disturbing the orbit of Mercury and giving it this weird orbit. But then as the instruments got even better, they said, oh, well, maybe it has a really weird orbit. So the Earth and Mercury are always on opposite sides of the Sun, so we can't see the Vulcan. They called it Vulcan. And it wasn't until Einstein's theory in the early 20th century that people thought, well, you know, maybe Newton's theory of gravity is wrong. And it's interesting that Avi brought up dark matter, because the same kind of phenomena is going on with dark matter. So dark matter is used to explain, among other things, the fact that some of the galaxies are spinning so fast that the matter in them is not enough to keep them from flying apart. So you add a bunch of invisible matter, right? And you get enough, and you know exactly how much invisible matter you need to keep them from flying apart. What people haven't done is say, maybe another theory of gravity is a problem. Maybe we now have the same situation with general relativity, Einstein's theory of gravity, that we had with Newton's theory. So science is very conservative, and often it makes progress slow, because what happens is people don't look at other possibilities. They don't explore other possibilities, even when the data is staring you in the face. And so I think, to be fair to Avi, that's the kind of situation that we have here. It's not that Avi, I don't think, is saying there for sure we've discovered extraterrestrial technology. What he's saying is we got to consider the possibility instead of proceeding on exotic ways of trying to explain it in terms of a dogma that we haven't been visited by extraterrestrials. So I think that both of you are right. I think that surprisingly, it'd be very surprising if technologically intelligent life were common in the universe. But as a scientific project, I think that Avi looking at the other possibility is really, really important. And I think that otherwise, you know, I find it really quite amazing. We could talk about unidentified flying objects. The same kind of thing here. There are pilots who actually seen them with multiple sensors. These are very sophisticated observers, thermal, visual, radar, and they've tracked these things. They converge in a single object. That makes it look like it's real, and it's behaving in ways that we just don't understand. But I have a friend who's an atmospheric chemist, and I ask her, tell me some interesting anomalies in atmospheric science. She says, I don't know where to start, because there are so many. So who's to know at this stage whether or not they are due to an atmospheric anomaly or we are visited by extraterrestrial technology? I don't know the answer to that, but I think both possibilities are worth exploring.
Thank you, Carol. We've got another question I want to throw out, but first I want to let Matt respond to your characterization as mainstream.
Yeah, so I paradoxically agree with Carol, who agreed with both of us, but not with Avi.
This is the wonderful position a philosopher can be in. Only a philosopher can be in a position like that.
But you did bring up the perfect analogy with Vulcan. So the idea that there was this planet between the Sun and Mercury, and so it was the French astronomer Urbain Le Verrier who discovered Neptune, by the way, by seeing a tiny glitch in the orbit of Uranus, and Newton's laws told him that there had to be another planet out there, and he looked and there it was. And this was an incredible success of just, theoretical discovery, discovering a planet in the math before in reality. He became very famous, was lauded as the greatest astronomer in France as a young man, and spent the rest of his life looking for Vulcan. And he found it twice. 2 times he found a speck, and he claimed that Vulcan had been discovered. And so here we have this interesting case where someone wanted something to be there so much that he found it, and we see what we expect to find. And for this reason, scientific conservatism, although it can be fraught, is built into the way we approach science. We have to be meticulous, we have to be careful, and we have to check what biases we are introducing into our interpretations of data. Urbain Le Verrier was curious but obsessed with what he thought reality had to be. It took another curious person to see through those prior assumptions, Einstein, to realize that it was gravity that was different. So I think Avi's characterization of the scientific community is, and fair enough because this is meant to be entertaining, is cartoonish. I think a good scientist does a delicate dance between conservatism and curiosity and tries to check their own biases, but understands that the more they want something to be true, the more careful they need to be. And also, Avi, I really want us to look for aliens. So I'm happy to correct you on that.
Can I just say something?
Go for it, Carol, go for it.
Can I say something?
Yeah.
Okay. So what I think is really interesting about this is the scientific community has not really wanted to explore the alternative position. And you get from the Pentagon all of this heavily redacted stuff about, oh yeah, these things are moving really weird. They're moving against the wind. They're going fast. They stop and they start. I'm talking about UAPs here. And we don't get the data. And so I think that what Avi is arguing for is going out there and looking, since we aren't getting the data from the Pentagon, and there's nothing wrong with that. I think that I think would I think that kind of treatment of anomalies where you do view the conservative, I mean, you pursue the conservative atmospheric science, maybe we can explain this away, but you don't just look for the conservative atmospheric science view.
If I may.
Yes, yeah.
Thank you, Carol. So, there are two ways to approach science. One is to appear on podcasts and claim to represent and protect science from people that may make statements that are not to the taste of the mainstream of science. That's one approach.
That's me.
The second approach, I said that's one approach. If you want to subscribe to it, you're welcome. The second approach is to actually be in the trenches and do the work of science, and that's much more work than sitting on a chair, speaking in a podcast, and leading the world's most popular podcast. That's not the way to do science. The way to do science is to actually... Wait a second, you spoke. I have the right to finish my sentences. The way to do science is to collect evidence, build observatories, collect data, and get to the bottom of the question that you're asking. And nobody within the scientific community has the right to say that this pursuit of evidence is illegitimate, because that's the fabric of science. It's a learning experience. The only way for us to learn about new knowledge is not by claiming and pretending to know the answer in advance. It's not by saying the evidence is not good enough and therefore we should not even think about other possibilities. It's the childhood curiosity, the imagination of other possibilities that should be encouraged, because it motivates the collection of new data. And the work that needs to be done to collect new data is to be celebrated, not the appearance on podcasts. It's the work to collect the data and evidence because we are curious. It's because the public cares about it. It's not that we are pretending to be smarter than the public and that we are not putting money into this research because it's not to our taste. It's too, how should we say, it's too interesting to the public, and therefore we should shy away from that. The way I approach it is two papers. One accepted for publication earlier this week in the Journal of Chemical Geology, refereed by 3 reviewers, all of which recommended the paper for publication. This paper reported about the findings from an expedition. We went to the Pacific Ocean, to the site of a meteor that the US Space Command had data on, and they reported in an official letter to NASA saying this object was moving too fast to be bound to the sun, therefore it was interstellar. And I said, okay, this is an interstellar object, let's go to the site where the fireball of this object was discovered and collect materials from the bottom of the ocean, 2 kilometers deep. A lot of work, planning for a year, this expedition, going there for 2 weeks, collecting the materials, bringing them back to the laboratory of my colleague at Harvard, Stein Jacobson, a world-renowned geologist, and analyzing the material for a full year. What did the mainstream of the scientific community do when I was doing the work? What did it do? What it did is first say, we don't believe the US government data. This must be wrong. Second, all they found is coal ash. And just to remind you, nobody in the scientific community had access to the materials. I had them in my hands. Why would another scientist say it's coal ash without having access to the materials, if not to just derail the process of scientific inquiry? And that, what I'm saying, all of these statements were made in published papers that were reviewed and published in the Astrophysical Journal. And why would someone publish a statement about materials that someone has no access to, if not to derail the process of scientific inquiry? That's what I have a problem with. And by the way, the reporters, the science journalists, reported about all these criticisms because these scientists were going around the community and saying bad things about the scientific work we're doing. The reporters use that because it brings clickbait to their articles. When I tell those reporters now that the paper was accepted for publication, being recommended by 3 reviewers, They don't care about it. It's not news. Why? Because who cares about the scientific evidence? All we care about is other people trashing the scientific process. Now,
Avi,
just 1 second. The second paper, I was going around, reviewing the draft last night. It's from an observatory at Harvard University that we built over 2 years to look at unidentified anomalous phenomena. The US government talks about military personnel, people that are reliable. And all we are doing is collecting data from the sky, trying to figure out if there are any anomalous objects. We looked at 500,000 objects. It's all reported in a scientific paper. All I'm trying to say, this requires work. To write those papers by my team requires work. It's not sitting on a chair and talking in a podcast and saying, oh, we have no evidence there was a wow signal 30 years ago. That's not the work. You're not doing any work by doing that.
Thank you, Avi. You're very passionate about it, and thank you for that. Can I move us on to another question, because we've spent some time on that one. I'm going to put this to you, Carol. Should we take seriously Elon Musk's claim that we need to go to Mars to find an alternative to Earth, however inhospitable?
I find that an absurd suggestion, and I'll tell you why.
To continue watching this video, click the link in the top left or in the description below.
With a free trial, you can enjoy the full talk and thousands more.
Thank you for being part of the conversation.